That's good.
Okay.
Thanks.
All right. So what we're going to do is we're going to go over problems and problems and problems. And okay. All right. So I'm taking advantage of this thing, and on Friday I came in and took some videos of stoichiometry. So if you haven't seen them, check them out, and hopefully there'll be some help. And I'm recording this too, so this will be online on YouTube as well. Okay. All right. So we're going to go over the first. It's called percent composition and molecular formula worksheet that I sent out about a week ago, a week and a half. We're going to go over that, and then we're going to go over maybe a worksheet that we're going to start working on today. And so this week is just basically going to be this stuff, finishing up. Okay, so number one, what is the empirical formula of a molecule that has 65% carbon, 5.5% hydrogen, and 29% oxygen? So what we're doing is we're going from percent composition to an empirical formula. So this information is in terms of mass. The empirical formula is in terms of moles. So you're going to do the, so just like when going between grams and moles and grams, okay? When you want to figure out how many moles you have, you divide up by the molar mass. And when you want to go the other way, you'll multiply. Okay, so you need to have molar mass. Okay, that's the key. Now, as far as the triangles go, what I'm doing is I'm just breaking it down into multiplication and division. But again, what it means is this, is that moles is our groups, grams is what we're grouping, and molar mass is the grouping size. Okay. For instance, in this problem right here, you assume that the 65.5% is the same thing as 65.5 grams. That's because the total mass you can assume is 100 grams. And so we'll put 12 here for carbon, 65.5 here for amount of grams, and then what you're going to do is divide this up into groups of 12. And that should be around 5. I don't know the number. What is it, 5 point? I'm going to need help with calculators, so somebody can get out a calculator. 5.4. 5.4. Okay, so as you go up, as we go up in moles, but we're going to divide into our moles. Okay. So we go the other way, we're going to multiply out. So I'm just going to pretty much stick with this. But the idea is, in terms of the triangle, is you're dividing up into moles and emptying out the moles. Okay. So we have 5.4. So we go from 65.5. Divide by 12, you end up 5.5 gram moles of carbon. 5.5, 1 mole of hydrogen. Okay, these are the percents that you're given: carbon, hydrogen, and then the last one is 29.0 oxygen. Divide that by 16, you end up around 11 point, I'm saying 11. What is it? What?
29 divided by 16 is 1.8.
1.8. All right. Okay, 1.8. Okay. Next thing you do is you find. So we need to have whole numbers here. You need to have whole number of moles. So what I do is you take the smallest number, and you at least get one of them, maybe all of them, in whole numbers. Take the smallest one, this guy here, divide through, and that gives you 1 oxygen, for sure. And when you do that, it almost gives you 3 moles of, roughly almost exactly 3 moles of oxygen, and then also 3 moles of carbon. Okay. So you go from grams, figure out how many moles, and then get whole numbers. So the empirical formula is that right there. Okay. All right, next problem is if the molar mass of this compound is 110 grams, what is the molecular mass? So what you do is, so this is the empirical formula. And what you want to do is find out how much it weighs and compare it to the molecular formula. And the ratio, if there's, it will tell you, the ratio of the masses will tell you what you need to do with the empirical formula. So the empirical mass is going to be 3 times 12, 36, plus 3, plus 16, which is 58. 55 grams. Okay, the molecular formula, the molecular mass is 110. The ratio of the two is, you need 2 of those to make one of these. Okay, so you're going to take this number here, because it weighs 55, you're going to multiply it by 2, you get 110. Because this is what's given to you for problem 2. And so it'll be C6 and 6, 2. Okay. If this would have been 55, you would have left alone and so forth. So the empirical formula is the lowest whole number ratio of the atoms. Number of atoms found in a molecule. The molecular formula can be the empirical formula, or it can be different. For instance, let's go with that again. For water, H2O, the empirical formula and the molecular formula are the same. There's 2 hydrogens and 1 oxygen for water. Okay. For glucose, this is the molecular formula. But the empirical formula is different. Okay. So when we do experiments, what we typically do is we find the empirical formula, and then what we have to do is find the molecular mass to figure out the molecular formula. Any questions? Okay, number 3, what is the empirical formula? Molecule with 18 point, so we're going from grams, okay, or percent composition. Again, you can assume that it's out of 100 grams. And we're going to divide by the molar mass of lithium. So this is lithium. Lithium is, we're going to say 7. I'm gonna round it. Usually rounding works okay with these guys. Carbon's 12, and 60 in oxygen, 5.0, 16. Okay, all right, 18.7 divided by 7 is,
2.7.
so there's 2.7 moles of lithium. 16.3 divided by 12 is
1.4.
and 4 point something.
4.1.
Okay. All right, so those are the ratios that we need to get in whole numbers. The other thing is that before we do that, let's take a look at what we got up there. We have lithium. We have lithium, carbon, and oxygen. Okay, what kind of compound is that going to be? Ionic or covalent?
Ionic.
Ionic, right, has metal in it. Okay. Is it going to be binary or tertiary? Tertiary, all right. What is the name of the compound? So tertiary is a metal plus atomic, polyatomic ion. There's only one polyatomic ion that we've covered that has carbon and oxygen in it, right? What is it?
Carbon.
Carbonate. So our answer is probably going to be lithium carbonate. All right. So that's sort of a way to test your answers. Usually these questions are not going to be things that are totally outside, it's crazy numbers. All right. So and the formula for it's probably going to be like that. Okay. So the ratio is maybe 2 of these to 1 of these to 3 of these, maybe, all right? That's what I would expect. Well, let's see if it is. All right, so I'm gonna divide by 1.4. That'll make this number here 1 carbon. All right, and when I do this is almost 2 lithiums. You really, if unless it's like a third or a half or 0.6, those usually just go up to the nearest whole number. Because if you have a 0.3, that means you probably have to do, it's a third, right? You have to multiply by a third. Or if it's 0.5, you have to do this a half, okay? So usually just don't worry about, if it's 2.95, that's close enough to call 3. And this one here is 3. And what is it? Li. Let's see. 3, 2. Yeah, just like you sort of guessed. So it's a good idea when you do these problems is, have them make sense. Okay, so the next problem says this thing weighs, so lithium carbonate weighs 73.8. That's its molar mass. So let's weigh this out. Let's figure out how much this weighs. Compare it to 73.8. And if they're the same, then you're okay. If they're not, then you have to figure out the ratio difference. Now, number 1, if they're an ionic compound, the ionic compound, the chemical formula and the empirical formula are usually the same. Okay. So I'm going to bet, without doing the math, is that is the molecular formula. Because ionic compounds, the empirical formula and the molecular formula are usually exactly the same. So let's see if that's true. Okay, so lithium weighs, what is it, 7? So 14, 2 times 7, 12 and 16 plus 12 plus 48, 3 times 16, 14 plus 12 plus 48, and 74. 74. Okay, so the same. So what I did with these two problems is I used knowledge that I knew that would help me know if my answer probably is right. Okay. Okay. The next set is talk about empirical formulas and finding out the molecular formulas from the molar mass and the empirical formula. Okay, so I have C2OH4. And that's the empirical formula. So what I'm going to do is find out its empirical mass, and then compare that to the molar mass of 88. Okay. And so this guy is 2 times, so it's 24. Plus 16 plus 4, it's 44. All right, the molar mass is twice that, so you just have to multiply this whole thing by 2. So you enter C4O2. All right, next problem, same idea. C4H4, oxygen, the molar mass is 136 grams per mole. Okay, how much is this weigh? 4 times 12, 48, plus 4, plus 16. So what is that, 58? 68. Okay, same thing as the top one. The molar mass is twice the mass of the empirical formula, so just double this. All right, next from CFBRO and 254.7 grams per mole. So what is the empirical formula? Mass and molar mass. All right, carbon's 12. Fluorine is 19.
Yeah.
Bromine is 79, so we'll say 80, just to see how close we are. And then 16, so 31, 111, 127, about 128. So we can see that that number is twice. So the molar mass is twice the empirical formula. So I have to multiply this by 2. So we have to do is multiply this by 2. All right, number 4. It says the empirical formula is C2H8N, and it weighs 46 grams per mole. So you have 24, 2 times 12, plus 16, plus 14. What am I doing? All right. Okay. All right. Great, man. Yeah, so you don't have to do anything with it. So the empirical formula and the molecular formula are the same. Okay. All right. Okay, number 9. Let's take a look at the question then. So percentage composition of acetic acid is found to be 39.9 carbon, 16.7 hydrogen, 53.4 oxygen. Figure out the empirical formula, and then number 10, we want to know the molecular formula. So number 9 and 10 we'll do together. All right, we already know the chemical formula for acetic acid. What is it? So, what is it? C2H4O2. Okay. All right. So, all this should make sense. Okay. So again, percentage, you can just change that to grams. So it's going to be 39.9 grams. So you have your, your grams. Carbon, so you can divide by 12. 6.7 divided by 1. And 53.4 divided by 16. Okay, and your moles. Okay, what's the mole? 39.9 divided by 12 is?
3.3.
This is 6.7. I can do that in my head. I'm smart. And I can do this in my head too because I know the answer. Okay. Okay. All right. So, okay. Divide by the smallest of these numbers, 3.3, 3.3, 3.3, and we get CH2O. So that's the empirical formula. So what we do is we figure out its mass, the empirical formula, then compare it to the molar mass. If they're the same, then the empirical formula and the molecular formula are the same. If they're different, then you have to multiply that ratio. The molecular mass will always be the same or more than the empirical formula. All right. Okay, so this will be 12 plus 2 plus 16 is 30. So the empirical formula and the empirical mass, we can see that this is half of 60. So I have to multiply, so this is half of 60, which is given in problem 10. So we have to multiply this by 2. And my goodness, they're the same, right? Okay. Okay, number 11 is a little bit more complicated. It's going to take a little bit more thinking. But this is a common way that we find formulas for things that can be combusted. So aniline is the starting material for urethane plastic foams, and it consists of carbon, hydrogen, nitrogen. Okay. And what we're going to do is combust it. So we don't know. So what we're going to do is add oxygen. These are always fun to do, at least to me. So we're going to take so I have aniline. I don't know its subscripts. I know it's, so A, B, and C are unknowns. And what I'm going to do is I'm going to add oxygen. And I'm going to end up getting carbon dioxide, water, and an N2. Okay. All right. So this guy starts out at 9.71 grams, and it makes 6.63 grams of this, 1.46 grams of this. Okay. All right, so these are so I boxed off the things that were given. I want to figure out how much carbon dioxide I made. So how much carbon dioxide was made? We don't know, do we? We know? I don't know if we can figure it out.
1.62.
How did you come up with that?
The two on the right.
Yeah, I was thinking the same thing. So forgot about this, right? So these two guys should equal these. These two guys should equal these three things. So we just can't figure out the difference between the two. All right, but we can figure some things out. First of all, where's the all that nitrogen had to come from this guy, right? Okay. So right off the bat, I know that this the nitrogen composition is going to be 1.46. Okay. All right. What is the other information? So how much of this is, so this is going to be, so how much is carbon and hydrogen? What's the difference between 9.7 and that number?
8 1/4.
Okay, so let's see if that can help us. Okay. So, 6.63. I'm gonna have to come back to it. Brain isn't working. So what's going on here? Where's the carbon? Carbon. Let's do this. Let's figure out how many moles these are. What's mole? So I'm gonna divide this by 18 and this by 28. Okay. So
First one is 0.368.
and what's this one here? This one divide by 28.
1052.
0.052 moles. Divide both sides by 0.052. Both of those guys by 0.052. So we get 1 and 2.
Like 7.1.
7.1.
Yeah.
Help me out. Okay, so I'm thinking this one through, all right? So so what I'm gonna do is say is that the amount of nitrogens is 2. The amount of oxygen is 14, hydrogens is 14. And then then I got CX. Okay, and does that help me? So this is, all right, I'm gonna come back. My brain is not. Some days I just get that one going, some days I don't. All right, I'll come back to it.